Fusion Mobile, quality e-learning experience on the go.
Formation, composition, and properties of soil. Soil is that portion of the surface of the land which is essential for plant growth. Talking about the process of soil formation, rocks which are exposed to the surface of the earth are broken up and changed physically and chemically to form a major part of the soil. There are many rock types with various mineral components. The number of different types of soil which can be formed from rocks are therefore plenty. Weathering, which is the first state of the formation of soils, is used to describe the processes which change a rock into a parent material or rock meal which later becomes soil. Weathering can be divided into the physical or mechanical weathering, biological weathering, and chemical weathering. The physical or mechanical weathering is the breakdown of rocks by physical or mechanical means which are achieved primarily by temperature. The actions of temperature, wind, ice, pressure, and water are important in this aspect. In temperature, the various minerals which rocks consist of expand when they are heated and contracted as they cool. Not all minerals expand and contract at the same rate. Some minerals respond to temperature more than others. As the various minerals in one rock react to the atmospheric temperature, they expand and contract at different rates. This produces pressures within the rock which over a long period of time causes disintegration. Winds. Wind carries away dust particles which when blown against rock surfaces can cause wearing away. Some sand dunes were carried by the wind and deposited in this way. Frequently, wind removes loose materials from slopes and exposes new surfaces. In ice, water turns into ice if the temperature is at or below 0 degrees centigrade. As water is converted into ice, it expands and increases in volume by about 9%. The force of this expansion is very strong, which is about 1,700 tons to the square meter. Pressure. Plants growing in the small cracks and crevices of rocks send their roots down into the cracks. As the roots grow larger, they cause cracks and breaks in the rock. When the pressure of upper layers of the rock is removed or lessened, deeply buried rock expands slightly. This expansion can cause many cracks in the rock above it, even in rocks such as granite. This is called release pressure. Water is one of the most powerful weathering agents, either as rain or as rivers, streams, seas, and lakes. Running water carries away disintegrated materials, partly by dissolving them and partly due to the rate at which it flows. Rock fragments carried in suspension grind against one another and also rub against the sides and beds of streams. This further helps to erode the surface of the fragments. Openings of various sizes called fissures or crevices occur in rock surfaces and water is often trapped in these openings. When the temperature is very low, water in these openings freezes and the ice formed in the cracks expands. Biological weathering. In biological weathering, the pressures inflicted on rocks by living organisms, that's plants and animals, cause small fragments of rocks to disintegrate. Agents of biological weathering include plants, insects and earthworms, algae, animals. In plants, the roots of growing trees may penetrate small cracks in rocks and exert considerable pressures which eventually split some rocks. In insects and earthworms, burrowing animals such as earthworms and termites eat their way into soft textured rocks, creating space for the entry of air and water, which are the main agents of disintegration. Their burrowing can also physically promote the disintegration of rocks. Algae. Algae are the dominant plant form in some mountain areas and Arctic regions where few other plants can survive. They grow into the rock surface by producing acids which dissolve the mineral parts of the rock and assist in its disintegration. I'm talking about animals as an agent of biological weathering. The pressure inflicted on rocks by animals such as man, elephants, cattle moving about, horses, etc. cause small fragments of rocks to disintegrate. The hooves of animals walking on the rocks break off many tiny particles. Also, animals like rats and rodents, which make holes in the ground, help in this disintegration of rocks into small particles. Chemical weathering. In chemical weathering, the chemical dissolution of minerals in water and the action of atmospheric gases such as carbon dioxide and oxygen constitutes chemical weathering, which is much more important than physical weathering. The action of water on minerals in rocks can cause simple carbonation, reduction, oxidation, solution, hydration, and hydrolysis. Carbonation is the process by which certain atmospheric gases react with water molecules to form weak acids, leading to the disintegration of rocks. Oxidation is the addition of oxygen to a rock mineral or the process of electron loss. During weathering, the most significant example of oxidation is the conversion of iron 2 to iron 3. We have different types of soil. A type of soil is determined by the rock from which it has been formed. The different types of soil are sand, silt, clay, and loamy soil. A sandy soil allows easy movement of water. It is therefore easy to walk or cultivate. It is well drained and aerated, producing early crops, but tends to suffer badly from drought and to be poorly supplied with minerals needed by plants. The washing away of mineral salts goes on at an excessive rate in the sandy soil. The properties of silt are midway between that of sand and clay. They are smooth, powdery, and have large surface area. They also have moderate temperature and are slightly sticky. The clay soil. The clay soil retains moisture very well, and they are usually richer in plant foods than sand. However, plant nutrients are held strongly and not readily available to plant roots. They are sticky when wet and difficult to work. They form lumps when dry and crack. They have poor air supply as a result of very tiny pore spaces. They also do not encourage the dwelling of living organisms. For example, the earthworm. They need lime, sand, and humus to be of good use to plant development. The loam soil. This soil is more fertile than either the clay or the sandy soil. They are made up of sand and clay particles with a high proportion of organic content. When the proportion of sand particles is higher, the soil is said to be sandy loam, and when the clay content is high and the sand content is low, the soil is referred to as clay loam. Loamy soils are moist, loose, and easily worked. They are rich in food and best for farmers and gardeners. Composition of soil. The soil, which is a thin loose layer of natural material on the surface of the earth in which plants grow, is composed of the mineral matter, the water, organic matter, and air. The mineral matter forms the greater part of the soil proportion of about 45% by volume. The mineral elements are part of the soil solids. These are rock fragments of various kinds, shapes, and sizes. These mineral matters include gravel, stones, sand, clay, and silt particles dissolved from the surrounding rocks. Its major function is to hold plants firmly to the ground, and it equally supplies plant nutrients and hold both water, which these nutrients are dissolved for growing plants. The soil is also made up of organic matter. Organic matter are decayed plants and animals and humus, which make up about 5% by volume of a normal soil. These are the sources of food to the plants. They perform the following functions, which include 1. Supply of nutrients to the plant. 2. Protecting the soil surface from direct impact of raindrops and erosion. 3. Maintaining good soil structure. 4. Improving air and water holding capacity of the soil. 5. Providing energy for activity of microorganisms in the soil. And 6. They regulate soil temperature. Soil is also made up of water. Soil water refers to the water that is present in the soil. The water content of soil is supplied by rain, dew, mist, etc., or irrigation, that's artificial application, and also underground water. Soil water occupies the spaces which air did not fill. Soil water forms about 25% of the total soil volume and dissolves minerals for plants to absorb easily with their roots. The water in the soil is held by many forces, on the basis of which soil water can be classified as free or drainage water, hygroscopic water, and capillary water. Only capillary water is available to plants. Water in the soil may be lost by evaporation from the soil surface, transpiration from the openings, that's of pores and stomata in plants, and the runoff from soil surface into streams and rivers. Water is important to plants in that it is used for transporting many food nutrients such as starch, protein, and fat to other parts of the plant where they are needed. It is an important ingredient in the manufacture of food for plants. The mineral nutrients in the soil are carried by water to other parts of the plant where they are absorbed to perform various metabolic and physiological functions. Water helps to regulate soil temperature. It is an agent of rock weathering, and all living organisms in the soil require some amount of water for survival and to carry out life activities. Water is therefore an important constituent of the plant cell. We also have air as a composition of soil. Soil air refers to the air or gases that are present in the soil. The gases occupy the soil pores which water did not occupy. Soil air forms about 25% of the total soil volume. The ability of air to circulate freely in the soil is called soil aeration. Air provides oxygen for the respiration of living organisms in the soil, and without air, seeds cannot germinate. Soil air is higher in moisture and carbon dioxide, but lower in oxygen than the atmospheric air. Soil organisms also make up the composition of soil. Soil organisms are plants and animals that live in the soil. They include earthworms, bacteria, fungi, and other higher animals. Animals in the soil feed on decayed plants and lower animals. The soil organisms improve the soil structure and the granulation. Through burrowing, they leave holes for the crop roots to penetrate. Small living organisms help to break down dead organic matter, in that it brings about decomposition of organic matter. These organisms range from large ones which can be seen with the naked eye, that's the macro, to those which can only be seen with the aid of a microscope, that is the micro. The macroflora, that's plants, include fungi, lichens, algae, etc. And the microflora include yeast, bacteria, molds, etc. Others are the fauna, that's the animals, like rats, termites, earthworms, millipedes, nematode, etc. Characteristics of soil. Soil is characterized by certain physical and chemical traits. Its characteristics are classified into the physical and the chemical. The physical properties of soil include the soil texture, soil structure, soil size, soil color, soil profile, soil acidity, and soil alkalinity. Talking about soil texture. Soil texture is the degree of fineness or coarseness of the particles of a soil. It can also be defined as the relative proportion of the various particles of a particular sample of soil. A soil derives its textural name from the proportion of sand, silt, and clay in it. Soil texture can be determined by feeling it, that's rubbing the soil sample between your fingers to determine its coarseness, and also by sedimentation. Sedimentation is a laboratory method where a soil sample is put into a measuring cylinder containing water and sodium carbon dioxide and is shaken vigorously. Another method of determining soil texture is by molding. Molding is a field method of determining soil texture. This sample is moistened and kneaded thoroughly and then formed into a ribbon. We also have the sieve method. The sieve is used to separate soil fractions depending on particle sizes into sand, gravel, silt, and clay. Soil texture is very important to the farmer because it helps to determine the relative proportion of air and water in the soil. It helps to determine the type of crops to be planted or grown, and it also helps to determine tillage practice to be adopted by the farmer. Soil structure. Soil structure refers to the groups or arrangement of soil particles to form aggregates. It can also be defined as the arrangement of soil particles, groups of particles, and pores among them. Soil structure has a direct effect on crop yield, and when choosing a site for farming, the structure of the soil must be taken into consideration. For example, a good soil structure must be well aerated, that is good air circulation. It must have good air circulation. A good soil has adequate soil organic matter, that's the humus. The humus improves the stability of the soil and prevents the soil from being broken up into loams. There are different types of soil structure, which include the prism-like structure, the spheroidal structure, the block-like structure, and the plate-like structure. The prism-like structure consists of particles that are like cylindrical pillars with spaces arranged in horizontal positions. The structure is usually the most noticeable in the topsoil. The spheroidal structure is also known as granular. It is aggregate with a lot of air spaces, and when it is porous, it is usually referred to as crumb. The block-like structure. In the block-like structure, particles in this structure have irregular edges which are either sharp or round. When they are rounded, they are called nuciform or subangular blocky. The plate-like structure. In the plate-like structure, the soil structure has pore spaces arranged in horizontal plates and leaflets. This type of structure is found at the subsoil. The soil structure generally is preserved by the planting of cover crops, mulching, and application of manure. Good soil structure will help promote good aeration, that's good air circulation. It will help prevent water logging. It would provide optimum amount of air in the soil. It will improve seed germination. It will permit adequate water retention. It will also make cultivation easy, and it will help reduce soil erosion and leaching. Talking about soil profile. Soil profile can be defined as a vertical section cut through the soil to expose its structure. We have different horizons of soil profile. They are the A horizon, B horizon, C horizon, and D horizon. The A horizon, also called the topsoil, represents the surface layer of the soil profile. This horizon contains more organic matter than other horizons. The B horizon, also called the subsoil, is the next horizon immediately after the topsoil. It is rich in minerals which are carried or leached down by percolating water. The C horizon, also called parent materials, represents the type of material from which topsoil and the subsoil are derived. And the D horizon, which is also called the bedrock, represents the unweathered rock materials. Soil profile is important because it helps to determine the level of soil fertility. It helps to determine the suitability of a soil for agriculture. A farmer can decide roughly what crops to best grow on it, and a loosely packed subsoil allows for easy penetration of roots of crops and also for easy drainage and erosion. Soil color. Soil color is the first characteristic of soil that you will notice. The color of a soil depends a lot on the color of the rock below. It is also affected by the amount of organic material it contains. A lighter colored soil is less suitable because more of the sun's heat is reflected than with a darker soil. Soil acidity. Soil acidity, which is also known as soil pH level, is the measure of the degree of alkalinity or acidity of a substance like soil. The measuring scale is graduated from 1 to 14. A soil whose pH is below 7 is said to be acidic, and above 7 is said to be alkaline, and it is neutral at 7.